is device plugin related. And Jain or maybe Renaud, you want to talk?
Sure. I guess I'll just share my screen and present the document. Give me a second. So the context of this topic is because we actually discussed this during the last resource management work group, and the consensus was that we needed opinions for more people about how to handle the design of the allocate call in the device plugin. So the device plugin currently has two main calls. There's one call that's called list watch that basically lists devices and tells the kubelet which device is healthy and which device isn't. And the second one is the allocate call that is used to actually communicate runtime information. And we at NVIDIA, and at least how I think we understood it when we built the device plugin, is that it would also be used to set the device, or at least execute device-specific instructions so that it could be used in a way to reset the device each time the container starts. And the current model is basically we would go over each container during pod admission, and we would basically, because of the init container behavior, we would basically say we have this group of devices that's assigned to init container 1. So in this case, GPU foo. We issue an allocate call, and then iterate over the rest of the next containers. If we see that container 1 uses GPU foo, then because we've already issued an allocate call, we don't issue it again. And if we see another container that uses a GPU device, we would issue an allocate call for that container and that device. And so if that was clear to you, and if that wasn't very clear to you, the document describes it a bit more. So that had a few pros, because the allocate call is issued during pod admission. So that means that if the device plugin becomes unavailable for some reason, at some point during the life cycle, so for example, a container restarts, we don't need to issue another allocate call, because we're basically caching the runtime information that's being communicated from the device plugin to the kubelet, and we re-inject it to the container. So we're checkpointing that information, and if the device plugin is not available, then well, we don't care, because we already have that information. So that means that the only problem that might happen is the device plugin is not available during pod admission, and in that case, we can just reject the pod. The problem is that, the first problem is that basically that's not a really good model, because that means that we can't really issue any device-specific instructions. In our case, for the NVIDIA GPUs, we can't reset the state, we can't catch errors that much. So for example, let's say your container restarts and it put the device in a bad state. We can't, the NVIDIA device plugin cannot try to fix that, or it cannot try, a simple example would be that, say you have a TensorFlow job, it allocates a lot of memory. So for some reason, the software crashes and puts, and the driver, the NVIDIA driver, could not reclaim the memory. Because we can't reset the device. When your container is going to restart, it's not going to be able to allocate any more memory, and your container is just going to crash loop. So that's not really a good production pattern. There's also the side effect that if you're using a GPU in an init container, because we're reusing the devices, basically I think, yeah. So basically, you would have a sharing between init container 1 and container 1, some kind of weak sharing where if you have the exact same problem with the container restart, if your init container puts your device in a bad state or just in a different state, then your container 1 will not have always the same behavior. So there's also a point that was raised during the fact that currently allocation, we don't handle partial failure correctly. But that's a different, I guess that's something that we could fix. It's not really a model.
Yeah, a small clarification. I think we do handle this partial allocation by doing the garbage collection data to track the usage of the active pods. So, but I think it's a small thing. Like we can continue. Yeah.
The point that was raised was more on the device plugin side, but I guess that's something that could be fixed right now. The other points are more about the fact that the model has some limitations, and the fact that, as we were actually talking with some of the Red Hat people that are using VFIO, or I was talking with them, VFIO and hypervisors. I don't know if they're here today, but they mentioned that the allocate behavior might also be the current allocate behavior might also be a limitation for them. But they mentioned that they would have to actually comment on that on the PR to confirm that.
So has someone summarize what's the limitation for current allocation? So I understand in the GPU support cases, and so current allocation, it is only done on the setup stage for the pod. So all the container restart, there's no allocation. So you want to have the way to solve this problem because due to the limited model and the potential of the corrupted memory, all those kind of things. So you just mentioned that in the OpenShift or Red Hat, using the allocate, there's some also limitation. What's that limitation? Can someone?
So, Don, that's a separate team. I mean, Red Hat's a bigger company, so I don't know offhand what that limitation was.
Yeah, it's maybe a different limitation. Like they may want to have some way to configure pod sandbox, or like also like for FPGA case, they may want to send the pod out container information. But I think it may be different limitation.
Okay.
So they have this. They have this PR that's actually referenced the issue recently, so we could look at it. But we'd need more information from them.
Okay.
I think they were playing with IOMMU, etc. So,
I guess what I'm curious is, like, we have allocate that does the allocate step. If we had another call that was pre-start container, is that a potential option, or would you do something differently in allocate than you would do in pre-start container?
So would pre-start container be something that would be in the container runtime, or would it be in the device plugin? Because I think the question is more, are you saying pre-start as a pre-start container pre-start hook, or pre-start as an additional PRPC method to the device plugin?
I think it is.
As an additional method in the device plugin. I guess what I'm wondering is, like, is there...
I think that hasn't been decided yet, and we do want to get some feedback from CRI people to say whether it's on their agenda to support a pre-start hook from CRI level. Right?
Looks like there's the three options. Right?
Yes.
So
exactly.
so when it is just change the current allocate model to per container, and are we going to still have the per pod? and how you're going to define per pod allocate and also per container allocate.
So,
I guess the question here.
So to answer your first question, I think we would still have a per pod allocate call, but it wouldn't be the model that we currently have, mostly because we're still going to need some kind of a call in the future when we start handling Newman topology. But the idea would still to have some kind of gRPC call that you could start, that would be invoked out of container start.
So second
Wait,
model second on the table, it is the pre-start hook in the CLI. So is that being discussed and designed?
I think it's actually have been discussed inside the resource management team, and I think it has been used by the NVIDIA device plugin to do certain container setup. So we actually want to learn like whether there's any plan to support this at CRI, because if we do have such plan, then we basically have two ways to do certain configurations, and we need to think about what functionality should be performed with the pre-start hook and what should be performed through the device plugin API.
So to give you more context, the way the NVIDIA device plugin works is that we're actually requiring your node to install the NVIDIA drivers and to install NVIDIA Docker. Currently, NVIDIA Docker is a Docker runtime. What it does is really it just repackage runc and adds this single line of code that says add pre-start hook. So currently, when you're using the device plugin, what it does is for every image, for every image that is being run, if it requests a GPU, executes the NVIDIA runc hook. And the question, what we've recently added is annotations in the device plugin API so that we could actually support CRIO, which CRIO, what it does is if it sees a specific annotation, it invokes a pre-start hook. And what we're hoping later is to actually maybe standardize that annotation that calls the CRIO pre-start hook to maybe something that would be more formal in this API.
Yes. Actually, there's also some similar request sent to the CI container. Yeah.
So,
Yes, the different code paths, but it's kind of same idea, same mechanism.
yeah, so the first question is, do we only need the hook in CRI, or do we also need it in Kubernetes? Because in Kubernetes, we don't have pre-start hook now.
Yes. Yuji.
I mean, maybe they know, because they propose the requirement. I don't know, do they actually need Kubernetes API change or just CRI change?
I can speak to that. It's Vishnu here. We do need changes at the CRI level. The idea that I proposed earlier was that we can have an exec call between create and start of a container, at which point you can get into the sandbox and do whatever changes you want. But in this context, I mean, I personally feel that the exec model or the pre-start hook model is better suited for changes being made in the container sandbox, not necessarily outside. The topic of discussion here is about managing devices, which is supposed to be in the purview of device plugins themselves. So I think, I mean, maybe we can just explore that option first before like diving deeper into pre-start hooks, which is like a little bit more difficult.
Right, because there's two things here. The NVIDIA specific operations that we need to execute when you're in a data center and you actually have to scrub the memory for security reasons or just reset your device because it's in a bad state. And there's the libNVIDIA container part where we're actually setting up the container so that it can run GPU images or it can access the different GPU features such as NPS and MPI. and for just OpenGL images, or even just normal images such as CUDA and deep learning images.
Yeah, Renaud, I have the same question as Derek. I was having the same discussion with Jai yesterday, in that it feels like we have two separate stages. One is allocate, which is meant to like just reserve a bunch of devices for a given pod. And then the second phase is like initialize or something like that, which is like trying to prepare the device for consumption, maybe at the container boundary or at the pod boundary. But in any case, like there seems to be two separate operations.
Allocate isn't meant to reserve a device, because we don't even have a deallocate call, and it's at least currently how it's used. It's meant to ask the device plugin what is the container configuration it needs, and how we're using it, or how we're hoping to use it, is calling the pre-start hook and setting some environment variable. In your case, it's more adding mounts and adding devices.
So again, like let's just not combine all these things together. There are distinct stages, and if you're saying that there is no necessity for having a special allocate call because of the fact that kubelet actually performs the allocation and there's nothing else to do on the device plugin side, then I mean that's a fact, and let's just leave it there. And then there's a need for initializing, which is what you're raising now in this conversation. And then there is a separate need for running pre-start hooks. So I'd like to like have them dealt with separately rather than combining them, because you can solve the problem of pre-start hooks in a different way as well.
I guess Vish, you are proposing the third option. I guess Don is also thinking about, like maybe you think we should introduce a separate method in device plugin
to the third model
to trigger this per container operation.
So that's a possibility, like Derek was saying. The thing that I'm not sure yet is, like Renaud was saying, is there a need for an allocate call? Like if the device plugin is not going to do anything with the allocate call, and if all its intelligence is only in the initialize call, then do we even need it?
Well, at least the use we're making of the allocate call is to tell our pre-start hook what devices to expose in the container. And that's something that we do need, at least at the allocate level. And there is, as you mentioned, the initialize part. But maybe that's something that could be solved by using this pre-start and sending the devices.
I think technically the operation can also be performed in the pre-start hook, right?
But that's the point that I was trying to make, is that the container pre-start hook is meant to execute container operations, and the device plugin to execute device operations.
Yes.
And trying to do device operations in a pre-start hook doesn't seem like a good idea in general.
Okay, so you are thinking like the pre-start hook is supposed to be executed in the container environment. So there are certain device setup operations that cannot be performed in the container environment. Is it the main concern?
It's more than trying to define API boundaries, so that you don't use the container pre-start hook to do everything. And I also think that from what I remember reading the sources, device operations might take some time, depending on what operations we want to execute, and when we want to execute them. And if I remember correctly, the CRI timeout for an operation is usually 2 minutes, and you can actually set that up. But I don't want the CRI timeout to be depending on the device you have on your node.
That's a good point. Yeah.
But we may also have similar limitation when we trigger this operation through gRPC. in the device plugin API.
Wait, I feel like we are combining.
Yeah.
Sorry, Don, go ahead.
I feel the run out, it is just try to see what it is, the scope, and each owner their scope, and also API boundary. So the device plugin actually understand what type of the device it is handled. So it's more like, for example, just take that simple example, timeout venue. It's more understand that how much they need for initializations. But the CRI is generic API, and it is for the to run the operation in the container context. So it is maybe if we override that kind of things, it's done. It's kind of a little bit we are trying to force ourselves to retrofit into that pre-start hook.
Okay.
Yeah, I mean, I just feel like let's just not talk about pre-start hooks at this point, because like even if we add a pre-start hook between create and start in the CRI, hypothetically speaking, the timeouts for that could be larger or longer. I mean, so I feel like that's a separate conversation to be had. Let's just like, I mean, it'll be easier for us if you restrict this conversation to whether we need an additional means in the device plugin API that will enable us to perform per container operations as part of the overall device lifecycle.
I agree, and I think one of the concerns we might have then, because you mentioned it, do we need an initialized call per container and a call at the pod level? One of the talks or one of the discussions we need to have is what operations should we perform at the pod level, because they might take more time, and what operations do we want to perform at the container level because they take less time. So, for example, I remember that, for example, I think that for some clients, for cloud clients, what we do is when we've seen a task crash on the GPU, we would run a test, and that test would take from, depending on the configuration, it could take from 30 seconds to 10 minutes. And maybe that's a discussion that we want to have, is that maybe we want to have that 10-minute test sometime to happen during pod admission or at the pod level. And we would only want to have, for example, memory scrubbing at GPU restart, memory checking, etc., or faster operations at container initialization level.
Yeah, so Renaud, that's a good point. And I think the assumption all along has been that most of these operations are going to be time consuming. At least that's how it has been inside Google. So that's a reason why the pod level was chosen. But I mean, you're clearly bringing up facts where per container level initialization is also necessary. So, I mean, it's at this point, it's just about figuring out which ones have to happen between container restarts, and then see if we need an extra initialize call.
Yeah, I think we are open to consider to make this a configurable behavior through device plugin API. So if some device plugin says I need to have this per container run operation call, then they can set this up during the initial registration, and then we will trigger this, and we will also clarify in the document like what kind of operations we expect the device plugin to perform during pod creation versus what we expect to be performed during container run. And basically, I think they should be lightweight, and that's the basic checking to make sure the container is in a good, the container runtime is, the running environment is good for device.
Yeah, I think it's probably a good thing to make it configurable. Though I'm not sure we currently have any device plugin that, or maybe Google's device plugin with NVIDIA GPU device plugin could be configurable. I'm not sure how you want to do initialize, but in general, I don't have any concerns about making it configurable.
And we probably want to introduce a separate method rather than like overloading the current allocate call.
I agree. I think we should have a separate per container operation in the API. Okay, so we spent a half hour on this topic. We can continue offline. So I think we achieved some agreement on this one, so can make more progress. And the next one is a log.
Sorry, Don, do you mind if we just, this was a 30-second agreement. We had discussed adding annotations into as a pass-through down to the device plugin API, which has a PR number open. I think I was in favor of the change. It seemed like most everyone else was in favor of the change. I wanted to make sure that there were no other disagreements with the change, and if not, I can tag it and unblock Renault.
I think we kind of agree, but can we kind of ask the UG also take a look and Nantal take a look, make sure the other runtime and is okay with site hunting.
Yeah, this would unblock for us cryo support with GPUs.
Actually, it's pretty. The PR itself is pretty generic. Just to pass the annotation from class plugin to runtime.
Yeah.
So
okay.
Yeah, I mean, as long as it's like annotations where it's opaque, that's fine. But like, I hope that NVIDIA doesn't standardize those annotations to be the standard way for dealing with different operations.
The annotation does need to be device resource specific because if two device plugins send the conflicting annotations, the behavior is undefined, and I think we just need to clarify this in the document. But
I mean, the reason I brought that up is because I mean, I've been working under the assumption all along that one of the key abilities with device plugins that we get is that it's going to be runtime agnostic. So I just hope that we don't paint ourselves in a corner where we have a matrix of runtimes and plugins and like OS distros, and then it becomes really hard for users to consume the overall software stack.
So I think this is one of the key disagreements we've had, is that it's by default it's not runtime agnostic. We're trying to have a single shared library that would allow us to at least have some kind of library underlying that would be common for all runtimes. But by default, it's going to be very dependent on what your runtime does. For example, MPI, we're actually going to have to mess with network namespaces, and it's going to be different on what your runtime does, and if your runtime is a VM or a container.
So I prefer that to be standardized as part of the CRI rather than like just be this whole runtime magic thing that happens. I mean, ideally, like if we can work towards a world where it doesn't matter which runtime you pick, as long as it's like Kubernetes compatible, then GPUs just work.
We can solve this problem in this meeting. So
I was going to say I've exceeded my time budget. So on the PR in question, if you can review it and agree that she's okay, that'll be the.
I want the VG kind of involved this one because he is the owner and on the CRI and also in this next quarter, he is going to in charge of the CRI productionized work and also roll out the plan. So she is have the most to say on that API. So I think we should. So we make that is generical. So next, okay. So then we can solve that offline.
Last comment. So I do hope like immediate people like Renaud and Felix. You can write a document to list to give us some details on why you think you have to use a pre-start hook, and I think this will help us make some progress on determining whether we want to support pre-start hook in the long run.
Sure. I think I've already had a document that was up last year. I'll try to probably copy it again.
Yeah, that's great. Thank you.
Can we move to log and logging, and directly you want to start logging improvement? Or maybe EG you want to?
No, I guess either's fine. So this was a topic that I think Peter Portante is on the call from Red Hat. So I guess, Peter, do you want to summarize the challenges we were facing? And this is more of a thought exercise to see if others in the community are having the same problem. And then if people have a particular preference towards a solution direction. So Peter, can you summarize what we discussed yesterday?
Sure. We would like to be able to collect logs and be sure we have the, if you will, coordinate or the location the logs came from as metadata collected with those logs without doing any additional API calls to Kubernetes to get that data. So today, if I want to know where a log comes from, and I could be mistaken, by the way, because I'm looking at, we're working with OpenShift 3.7 and 3.8, which is not the latest Kubernetes, but today, a log file going through, say, the Docker runtime, where you've got a JSON file configured log driver, on disk, you know the name of the pod, you know the container ID, you know the pod ID, and you know the name of the namespace, but you don't know its UUID. And so if I later need to disambiguate across namespaces using any historical records in the logs, and I have any changes to namespaces that have happened over time where a namespace gets reused, I potentially will have an overlap, or I won't be able to disambiguate the by namespace UUID. Now, I could, as a log collector, make the API calls to go fetch the UUID of the namespace at the time that I'm collecting this to ensure that later I am unambiguous, but that seems really inefficient for that case. Certainly there's a case where a log collector may want to enrich the logs with optional metadata that's convenient or nice, etc. But the only data that I'm aware of that you need to completely disambiguate where a log comes from is listed in that ticket that's, or that issue that's posted, which is hostname, container UUID, and its name at the time, pod UUID, and its name at the time, and namespace UUID and its name at the time. And I believe today we're missing namespace UUID in that metadata. If we had that, then we can collect this data, the logs, without any other APIs calls made to enrich and still have all the proper location information for the logs. Does that make sense?
Totally makes sense to me.
Yeah.
It's not a backward compatibility issue, or I'm sorry, I don't see anything.
Yeah, so I guess generally speaking, like we want to make sure that things are unique across space and time, and obviously Peter did a good job describing the namespace side. The challenge I'm trying to reason through, and I'm just curious what people's perspective on is what the right way of fixing this is. Like at Daily, it seems like Peter wants it to make it that the path that we log out to includes that identifying information, and that's one option. And if we all agree that that is a approach we could take, like, yeah, there's a compatibility problem that we have to run into. But then also, generally speaking, like, do we want the kubelet to have to be looking this up? Or should we start pursuing a path with SIG API machinery so that on object meta, you always have the namespace UUID present next to the namespace name? Both, either path takes time, and I guess we could iterate in one direction first and then go and get the API improved. But I guess generally, how flexible do we feel as a group about where we log to and the location metadata that might include?
I think you do have some comment.
Just looking at the issue, so this is not really a CRI specific issue. I assume this has been there since the beginning. And actually the way that's described in the issue right now, that looks more like the original old path, not the new CRI path. In the new CRI path, we have the pod UUID actually as the directory name, but we don't have the container ID anymore because we create a log path before even creating the container. So kubelet has no way to know what ID the runtime is going to assign to that container. So yeah, it's a mix of.
But the namespace information is still lost, right? I guess that's the.
Yeah, but you have the UID, which supposedly can uniquely identify that pod.
Well, it uniquely identifies that pod, but if the thought process is not about the time at which the logs happen, it's what do you do with the logs after you've collected them? So, for instance, if I am looking at, the morning's logs at 8 p.m. at night, and during the day, multiple changes have happened where people created namespaces using the same name, and they're allowed to, then when I collect those logs in the morning and I'm just looking at them in the evening, there's possibility that I can do searches that pick up logs from multiple namespaces that have nothing to do or related to my original logs. And if I just restrict by pod ID, that's okay, because I can use pod UUID and I'd have only logs from that pod. But if my namespace has multiple pods in it, and I'm trying to look at my larger namespace on things, then I potentially am going to be trying to cross the pod boundaries. And it's that crossing of the pod boundaries where the people are given in the namespace access, or you generally associate what's in your namespace together. Or if not, you generally do it. It's reasonable to assume that someone would have multiple pods that would be related within a namespace. And it's in that spirit, not at the time the pod is written, but later when you're doing kind of forensic work, that you'd want to make sure that you differentiate and disambiguate the namespaces you're choosing across. And the only way that you can do that is getting the UUID of the namespace, because it is possible for namespace names to change and be reused. And so if you don't decorate the logs with the namespace UUID, then you run the potential of getting all kinds of logs collected together that just aren't associated with each other. You can also, for the case of multi-tenancy, where someone does multi-tenancy on a namespace, then the namespace UUID can't help you differentiate the logs across the tenancy, and then you have the potential to leak logs across multi-tenancy domains. So, so in this spirit, if you just do pod UID, which is okay to know that all the logs came from a given pod, it doesn't help you with the larger forensics or the larger correlations you might want to make beyond that. In history, so obviously at the time, you can make the argument that, well, just do the API calls and find out what the UID, and at that point in time, you know what to go do. However, even there it's hard, because if I only have a pod UUID, I need to still somehow find out the pod name to do any queries about the pod metadata, right? I can't do a query by UUID that I'm aware of. And once I get the pod metadata, I only have the namespace name that was assigned, that this pod has at the time that it was done. I don't have its UUID. So if I try to do a lookup of that namespace name later to figure out what the UID was, I potentially will be getting data about another namespace, not about the one that's associated with this pod. So
yeah. I think, Peter, we rocked the problem, I guess. I don't know, if I'd like to focus on a solution that was around the CRI. I just wanted to make sure if folks were aware of the problem, and then if there was an appetite to change the path by which we log in potentially this cycle to, unblock Peter here, or if there's any concerns about that.
Yeah, I'm open to changing the path. Actually, I've asked Nick from our GKE logging team to look at the path and see if it's enough, but he's been out for a few weeks, so he'll come back during February, and I think he'll be involved in this work too.
Okay.
So the big concern, obviously, I'm totally agree with what Peter did, and I pro this approach. The big concern it is just backward compatibility. So we need first to solve this kind of things to see what it is. Is there any risk caused by the backward compatibility for our customer, right? Because Kubernetes is in production many places. So so we need to solve that one first. And at the same time, I think this is actually it is. We may need to change some API, or maybe we want to Kubernetes do some dirty work and query those kind of things, and before the write to the disk, all those kinds of things is implementation detail we can discuss. after we saw, we understand the backward compatibility issue.
We do have a new CRI path, and then we still have the old sim links for the old paths, which we actually use today. So changing the new ones are safer, but doing the transition from the old to the new CRI path will have the issues you mentioned. But anyway, we'll run into those issues. So it's better that we just come up with a better CRI log path right now before we do the transition.
Okay, so how about this as a plan forward then? So Yuju, I missed the name that you said.
I was speaking on the issue. So
The big instrumentation is also CC and Mac, and the Yuju also CC to Mac already.
Okay, so I guess we'll wait for them to return, and then Peter, you can pair up with them on a path forward. Does that sound good?
Yep, we'll do it through the issue, right?
Yep. All right, well, thanks everyone.
So next one, actually, it is a log status proposal, and someone posts the stats. Yeah.
Somebody here?
Yeah.
Great.
Yeah, can you guys see the screen?
Yes.
Okay. So we just wanted to have a small proposal on log stats. So currently, log stats are being used for storage policy enforcement on the nodes, because kubelet is managing the shared storage on the nodes, and also for evictions, for summary stats, APIs, and things like that. And most importantly, it's used at the container level, so we would need container level log stats. So currently for Docker, C-Advisor collects our container stats, so it's a different code path. But for CRI, the log stat collection is at the pod level. So like the log path is /var log pods, and then the pod UID with the container name and the instance. So it is specific log file name. With this, there's no way for us to monitor the log stat, because we're pointing like some of the runtimes are pointing the pod directory for monitoring the logs. So this might cause regression in our summary APIs, a monitoring pipeline, again, eviction strategies and things like that. So we wanted to make a small proposal on what are the options we can pursue. And option one being, like, we can point the C-Advisor to directly point to the container log file itself. So this will be like a more easier workaround. But this might be temporary because we have the log rotation coming in this release. So if the log file name keeps changing, then there's probably no easier way to monitor the log stats per container. The second option, which I think which is also a preferred option, is to create subdirectories per container. And kubelet can point this. Kubelet sets this, creates this subdirectory under the pod directory, and then points that to C-Advisor to collect the stats for the container. So if there is log rotation, the log files are created within the subdirectory. So as long as we monitor the subdirectory, it should be associated with the pod itself. But the problem there is, again, we might break the CRI backward compatibility. So we probably may not be able to support like newer kubelet, new Kubernetes version with an older CRI runtime. So we'll probably have some breakage there. And also, if it also depends on how long we plan to support C-Advisor integration for collecting the stats. So with option 3 is the container runtimes themselves support log stat collection. Container runtimes may not be aware of the log rotation that happens, because log rotation will be done by kubelet. But we need to have some capability for container runtimes to integrate with C-Advisor or be able to give out the stat results for the logs per container. And also, it might be just redundant work, because given the fact that all the CRI runtimes pretty much have a standard log format, so it might just be redundant work to implement these in each of the runtimes. Last option is the kubelet itself monitors the log stats, because kubelet is doing the log rotation as well. So it's is probably the logic might be better suited in the kubelet itself to monitor the container logs to generate the stats for it. So it's up to the people, like if there's any opinions or options in addition to this to get some consensus.
One thing is log rotation is still in discussion, so I pasted the link of the evaluation and proposal in the meeting notes. So basically, we do want to finalize log rotation for in this quarter, and this is a doc that's summarizing different options, and I did pick one as a proposed solution at the end. So feel free. I don't think we'll go into details about the stock today, so feel free just to comment on it.
So the current suggestion to let kubelet do log rotation.
Yes.
Yes. So actually, and also we did think about all those kind of solution list here, and at the end we kind of conclude. We discussed this at the SIG Node before, and we can kind of conclude, but it is open for the review and suggestion and the comments.
And yeah, sorry, it's not a GitHub proposal. It's just easier that way. If people want it, I'll convert it to a GitHub proposal. And if suppose that we decided to settle on using kubelet to rotate the logs, then I think option 4 here actually may make more sense. To let kubelet just report it.
Option 4 means we need to write new monitoring code or maybe copy from SIG-divider.
Yeah, some simple code. Because if kubelet is going to do a rotation, then we also need new code for kubelet to rotate the logs, and that could also include just reporting the stats.
Okay. What about option 2? What do you think?
That depends on how long we are going to use the advisor for this.
That one actually we talked, right? So there's a SIG-divider. It is that destination is undefined. Many people want to replace the SIG-divider and separate the monitoring pipeline. There's the many work done, been discussed. It's not really work really done, but it has been discussed many times. And Derek, shouldn't
I think
we want
last
to.
time when we chat, Quell is currently still in the first option, and I think maybe they also have some opinion.
SIG-divider wouldn't require a ton of work to be able to monitor extra paths. It already has something like that built in. We just don't use it, or maybe we do, but I don't remember. But it can.
So I think option 1, well, at least option 2 seems like a possibility, so that we will, well, kubelet itself, whether it's from SIG-divider or not, will get some stats instead of runtime. It's easier for this quarter, then we can do that.
Is there any blocks on other work?
You mean this one?
Yeah.
Because without this one, we cannot provide inner log stats, and some API is not complete, and this division, part of this division doesn't work. Yes.
So how about we are for temporary to using the option 2, and then we work on the option 4 for long term.
Option 2 does change the path though.
Yeah.
So I think all 3 issues are sort of coupled together right now.
I do think it makes some sense at least to have a generic way to monitor CRI logs since it's standardized via the kubelet. So I don't think it makes sense for every runtime to implement it themselves.
This is a current agreement, but that's long term.
Yeah.
For short term, we want to unblock people make progress.
So I had trouble hearing, Don, what the short term option is that's being discussed?
Actually, we didn't really have any short term.
Okay.
And here, yeah. So we are talking about in the logging rotation, we are talking about the option 4, which is we kind of agreed last year.
Yeah, that makes sense.
But not everyone actually reviewed that doc, I believe. And but short term, it is we don't know yet.
Okay.
Yeah.
So yeah, one short term option is option 2, but that requires changing the log path.
Yes.
To have a separate directory for each container. So that also affects
backward.
Yeah, what you propose about changing the log path.
Yeah.
I guess it also depends on how soon or which release the log rotation is going to come in, right? Because otherwise, option 1 might just be the easiest workaround. That's going to be temporary until log rotation.
We do want to target having a log rotation done this quarter.
Okay.
Oh, yeah.
Yeah, I think short term we can treat logs somewhat how we treat images, and that we will perform actions to decrease the number of logs when we're under disk pressure, but we don't necessarily account them per container, and we can add the accounting after we have rotation. Is kind of a short term.
Have we considered a back pressure method to slow down the rate at which the logs from the container are emitted?
Yeah, so this was also mentioned in the log rotation proposal. Personally, I haven't thought about doing this much. I haven't heard anyone who requested these features. But
so this is a pretty common request among new users. Like, it's kind of the two trade-offs is you're either generating log output that you expect to be meaningful, and in the absence of info, we expect log output to be meaningful. Or you know that it's not meaningful and you're willing to trade it in order to get availability. It's a pretty fundamental choice. I'm not sure that we are always able to make that decision at a cube level for every consumer. And so giving the choice, you know, at a pod or container or whatever level does make sense in the long run.
I've been working with a couple of customers recently that care about every single byte that comes out of the containers, and they don't want to lose anything. And that's a very difficult thing to guarantee right now.
Well, and if every byte matters, then pushing the problem, like putting back pressure, is appropriate. And if every byte doesn't matter, then it's really not something that you want the container to have to worry about. That trade-off is really very similar to the trade-off that we have for persistent volumes.
Right.
Giving people a spectrum of choices and then letting them choose.
So even though it's a fundamental problem, but I feel like it's more like a new feature request. And given that this quarter we try to focus on getting the CRI logging, it is up to par with no regression. This is unlikely to be addressed immediately in my opinion. Then maybe we can file an issue and then discuss this as an advanced feature in the future.
We run out of time, so we have the 2 topical. We didn't, or 3 topical actually we didn't cover, and so I believe there's also the Windows Container Resource Management. They come back because last week we gave some like the high level suggestion, and I believe they revised that one, and we should do this. They came back to ask for review, and from the SIG Node community, and another one, Derek, we are going to reschedule you're discussing about the new remedy system, the proposal next week. Is that okay?
Yeah, that's fine. I guess what I was interested on that one is if I wanted to, assuming we had agreement, start the process to get a repository that some engineers could start delivering code and design documents to. And so I guess I can do that in the interim if we have no disagreement on having a incubated pair to the node problem detector, essentially.
Yeah.
Okay. All right. Well, I'll send the note out to the right folks that need to be, so we get the repo there, and we're good to go. Thanks, guys.
Yeah. Thank you. Thank you, everyone. Talk to you guys next week.
Thank you, everyone. Bye.